All right, my great 12 learners, those of you writing May, June, recording this video as part of me assisting you for your get ready for your May, June exams. I wish you the best of luck, because we might not have time to go back and revise all this work that we've been doing, considering that we have to finish the syllabus in like 2 to 3 months, and all that. I am doing these videos so that you guys can use them as part of your practice purposes, as part of your practice, okay? I'm not going to be explaining in depth some of these things because we've done them in class, but I'm going to try as much as possible to try and get you to the feel of it for you to understand some of these things that are here, okay? The first thing that we can see in this question is that this is Newton's second law, which is question 2. We're going to go through this question. Please bear with me if I struggle with the drawings. I'm still struggling to work on the drawings, but I'm going to explain this as easy as I can, okay? Or the best way possible. Now, here in this question, we have two blocks, one which is 4 kg and the other one which is 9 kg. The two blocks are moving up an incline with a speed or with an acceleration of 2 meters per second squared. Okay, this is what we can, or this is what we are told here. This is the 4 kg block and the 9 kg block. On the 9 kg block, there's a force that is being applied, which is force F. Okay, we don't have the value for that. I'm not going to go through the entire statement. We're going to look at it here when we get to this point. But here it says we must state the Newton's second law of motion in weight. Okay, remember this is derived from the formula F net is equals to ma. So what does it say? It simply says that when a net force is applied on an object, the object will accelerate in the direction of the force or of the net force. The acceleration is directly proportional to the net force, but the acceleration is inversely proportional to the mass of that particular object. Okay, please make sure you know all four of Newton's laws: Newton's first, second, and third law, and Newton's law of gravitational acceleration. You really need to know that. Okay, one of those definitions might be there in your examination. Please make sure you know all three of them. So I'm going to go on to the second one. The kinetic frictional force acting on block A, so block A, which is this one, and B, which is this one, is 5,88 and 13,23 respectively. So for this one, it means that we have 5,88, and for this one is 13,23. All right, so these are the kinetic frictional forces acting on them, okay? And then it says here, you must draw a label free body diagram showing all the forces acting on block A. So what are the forces that are acting on block A? I'm going to try and see if I can draw the free body diagram for us. Okay, so this block is sitting on something like this. So this is our block. I told you to forgive my drawings. So forget about it. Okay. What are the forces acting here? There's a force that acts perpendicular to the surface, which is 90 degrees to the surface. That force, we refer to it as the normal force. We explained the normal force, but this is a force that acts perpendicular to the surface. It is only there when there is a surface, okay? So when there's no surface, there's no normal force, because there's a force that is acting perpendicular to the surface, okay? That's the first one, is the normal force. And then every object on Earth that occupies space, it must have mass, which means that it will have weight. So this is the force of gravity. Because of mass, we have to have weight. And if you look at this here, this is a string pulling the object upwards, and whenever there is a string, there needs to be a tension force. So the other force here is going to be what we refer to as tension. You can write it as Ft or T. It's absolutely up to you. Okay. It was mentioned today that there is going to be a frictional force, that this object has friction. My frictional force is very long. Let me just take an eraser and erase this part and just put it like this. Okay, so on this other side, I'm going to have my Fk there. Okay, so these are the four forces that will act on this object here. What am I doing? This is going to take me some time now. It was written correctly. Now, okay, the diagram, you'll forgive me there. I told you that this is my struggle. Okay, but now that we have this, you must remember to always include all the objects that are on an incline. They will always have your FG perpendicular, which is perpendicular to the surface. Please forgive the drawing. It's supposed to form an angle of 90 degrees with the surface. And then they will have FG parallel. Okay, FG perpendicular is the mass, gravity, and the cos of theta. And that is, we can just calculate it for the 4 kg block. It's 4 times 9,8 times the cos of 35 degrees here. And that will give us, so let's see, it's 4 times 9,8 times the cos of 35 degrees. It's 32,11 Newton. That is our FG perpendicular, and our FG parallel, which will be mg, the sine of theta. This will be the mass, which is 4 times 9,8 times the sine of 35 degrees, and this is equals to 4 times 9,8 times the sine of 35. That is 22,48 Newton. Okay, so you need to have this. They are going to be very important for you. For this question, really, FG perpendicular is not important because we are already given the kinetic friction. But FG parallel is very, very important. Now, we know that the forces that act perpendicular to the surface are doing no work on the object. So, meaning I'm a boom. Now, I'm going to remove them for the purposes of the calculation. Okay, so I'm going to remove the forces that act perpendicular to the surface. Because I've already written the components of Fg, I will also remove the force of gravity. So I'm going to be left with these three. So typically, what am I saying here when you look at me saying this? Only these forces that act on or that act parallel to the surface or in the same line with the surface, okay? Only those forces are going to give you your net force. Lama force la acta like line. Ngizama draw a line le incline. La acta like line leli. Ngiyo la tokunigeta ini net force. So the other forces you can just ignore them. Remember, but we explained in class, good see, why are we not including them? Because firstly, they act at an angle of 90 degrees, which means that they are giving us no work. We can say that, or they balance each other, the force of gravity as well as the normal force. Normal force is equals to the force of gravity in this particular question, which means that they are going to balance out. Okay. Now, so we have 1, 2, 3 forces that are giving us the net force. So these 3 forces here are the ones that are giving us the net force. Let's quickly go to the other question here. It says calculate the magnitude of the tension in the string. The tension in the string, the T here. We can use this block to calculate it, or we can use this block to calculate it. We will use this one. Why? Why are we not using the block B? Instead, 70 is a block A. The reason for that, you see on block B, we have force F here, which we also do not know. So if we use block B, it means that now we're going to have two unknowns. So that might complicate our life a little bit. We want things that are simple here, okay? So let's use block A. If you use block A, this is what we are going to have. You're going to say your net force is equals to MA. Remember, net force is equals to is the sum of all the forces acting on the object, okay? We've left out the perpendicular ones because we said they add up to 0. Now, we need to choose a direction that we're taking as positive. In this case, I'm going to say up the incline as my positive. So what does that mean? It means that I'm going to have tension that is positive plus net force is the sum of all the forces minus FG parallel. Why is it negative? Because it's going downward and we said up is positive. Plus minus FK, this is equals to MA. Okay, tension minus FG parallel for this block is 22,48 minus kinetic friction for this block we were given is 5,88. This is equals to 4, which is the mass, multiplied by 2, which is the acceleration. Okay, now when we get here, minus 22,48 minus 5,88, what does that give us? So T minus 28,88 is equals to 8. Okay, now we will transpose this to the other side, which means that T will be equals to 8 plus 28,88. So if I add here 8, this will give us now a tension force which is equals to 36,36 Newton. Okay, that is the first question. They're calculating the tension of that particular object of the caused by the string. Number 2, it says we must calculate the force F. Okay, we must now calculate the force F. I usually say I prefer us to have a free body diagram before calculating anything. So now we are talking about our other block, which is the 9 kg block. I'm just going to put it here. This is the 9 kg. What are the forces acting on the 9 kg block? The first thing that we know, it must have, I'm trying to draw a straight line. You will forgive me for this one. It must have a force of gravity. It must also have a normal force. There is a force that is being applied on that object, which is force F. We know for a fact that that block will also have, where's my rubber? That block will also have a frictional force. We were told about this. Okay, it does have as well a tension force. If you look at this, this string is also attached to the 9 kg block, which means that the 9 kg block must also have tension. Okay, so we're going to also include here the tension force. It's not supposed to look like this. It's supposed to be straight. Hey, I wanted this thing of lines. So tension force D. You will forgive my drawing once again because it's not supposed to be looking like this. Okay, now let's put our FG perpendicular, which is mg cos theta. We didn't use it last time. I'm not going to calculate it this time. It's wasting our time because we don't really need it here. We need it when we need to calculate the normal force. We don't need to do that here. So here we're going to have our FG parallel. Remember, FG parallel, we do use it, and it's mg, the sine of theta. The mass of this object is 9. G is always 9,8. And this is the sine of 35 degrees. Let's see what is the FG parallel here, 9 times 9,8 times the sine of 35. This is equals to 50,60 Newton. Okay, now that I'm here, I'm supposed to calculate the force applied, which is force F. The formula is the same. I can do the same thing I did before. I'm going to remove all the forces that are not in the surface we are talking about. Now we're talking about this inclined surface. I'm only interested in the forces that act on that particular line. Okay, so these are the forces that I'm interested in. These forces will give me my net force. We'll start by saying the net force is equals to MA, just like before. I will take up the incline as positive, which means that I will say now the force applied is positive plus minus the force, the kinetic frictional force, minus FG parallel minus tension. This is equals to MA. Okay, the force applied is what we are looking for. That is force F minus FK for this was given as 13,23 minus FG parallel, which is 50,60, minus the tension force, which we've calculated in the previous question, and we got it as 36,36. This is equals to 9 multiplied by 2. Okay, 9, which is the mass, and 2, which is the acceleration. So let's put these things together. Negative 13,23 minus 50,60 minus 36.36. This gives us F minus 100,19 is equals to 18. 2 times 9. Okay, the force applied then becomes plus this goes to the other side, so it's 18 plus 100,19, which means this is 118,19 Newton. So that is the force that is being applied, which is force F. Okay, so we've calculated force F. Now let's look at the last question, which is question number 2.4. The angle that the plane makes with the horizontal is now decreased. So we are decreasing the angle. How will the kinetic frictional force acting on block A change? Will it increase, decrease, or remain the same? Okay, the best way to do this is through calculation. I always prefer you guys to use calculation to explain these types of questions. So what would you do if you were using calculation to explain it? You would just decrease this angle and calculate the normal force. If the normal force increases, it means that it simply means that the kinetic friction is going to increase. If the normal force decreases, it simply means that the kinetic friction is going to decrease, because normal force is directly proportional to the kinetic friction. Okay, but when you decrease this angle here, the normal force is going to increase. Okay, when you decrease the angle, the normal force is going to decrease. So to increase, if the normal force increase, so I'm going to firstly write that this is going to increase. What is my explanation here? The normal force increases. In normal force is directly proportional to kinetic friction. Okay, but how do you prove then? You can say normal force is equals to mg and cos of theta. Use the angle on both sides. So firstly put the 35 on the second one, decrease the angle. If you decrease the angle, you will see that the normal force here is going to decrease in size. It's going to increase in size, which simply means that in this particular question, the kinetic friction is going to increase. And then you explain your answer. I've just explained it to you. I'm so tired.